In this video, we are going to go over chapter 6.1, and the topic on 6.1 is an area between curves. It is very similar to what we did in towards the end of chapter 5. What we are going to do is we are still going to find the area under a curve. Instead of one, now we are going to look at two curves. So here's the general idea. If you go to slide number 3 of your PowerPoint, you have a two curve instead of one, f of x and g of x. In the past, we were considering this whole entire region, right? But instead of that, now you're going to be focusing on two curves, this curve, the blue curve, and then red curve, and then only find the area between the two curves. So if you approach geometrically, this is what you are doing. Basically, what we are going to do, we are going to find the whole entire region of the blue curve, this one. That's what it is, area under f of x. And then if I also find the area of this orange one, right? We know how to do that by the fundamental theorem of calculus. That's what we did, one curve at a time. Now, if you look at the blue one, subtract the orange one, then you're going to have this remaining piece. And that's what the area A between f of x and g of x is. So we are basically doing two area and then just subtract between the two. Now, here's the catch. So this is what formally written. You have a to b, some a and then b, and then find the area between the two and subtract. Now, note, very important, that f function is above and then g is below. So we are always going to have the top function minus the bottom function, okay? So that we get a positive area. So we want the area is a positive. So we want to take always the greater one, subtract the smaller one, and then find the remaining piece. F of x is top and then g of x. So top minus the bottom. Okay? So let's write that out on our notes. So here's our 6.1, and this is what you saw. F of x minus g of x. So we have a top minus the bottom piece. The theorem is set it up as a top first and then always the bottom one. And this is another definition, Gini index of income concentration. And this is, you can use it for the application problem. The equation is twice of 0 to 1 x minus the function f of x dx. Okay, we'll use it if the problem requires us to use the Gini index for the application problem. But let's begin with the first one. I'm going to do a couple of them, and then I'm going to leave a couple exercise for you to work on. So I'll be working on like one and give you the next one, and then I'll do the next problem, and then I'll leave out the other one for you to work on. So you get some practice. Number 1 through 7, find the area bounded by the graph of the indicated equation over the given interval. Compute the answer to 3 decimal place if necessary. So we will round it to the 3 decimal place. Now first, you have these two functions. Notice f and g. And we have to decide which one is the top function and which one is a bottom function, right? So I'm going to graph using the graphing calculator. And then we have 8x cube minus 2. And then the second one was a y equals 0. And then we want to look at from 0 to 6. Let's graph it. Okay, now you know that y2 is just a single line, so it's a horizontal line right there. So we have from 0 to 6. Now take a look at this. First thing, there is an intersection right there. And you can see that intersection point is at 0.625. You can see on the bottom piece, right? Right over here. Somewhere here we have an intersection. Now, let me, okay, so intersection right over here. Let me capture this and then use that. I'll just use this one. Okay. I'm gonna leave it over here and then comment about this graph. Now, if you look at this graph, here is my intersection point. Now, this is in decimal, so I'm actually going to solve that intersection point by setting these two equations because I don't want to use rounded answer. So that's what intersection point means. We set 8x cubed minus 2 equal to 0 and solve for x. I'm going to be adding 2. 8x cubed equals 2 divided by 8. That will be 1 over 4. And then cube root it. I have x is equal to, and then I rationalize it. It's cube root of 2 over 2. So that's what this is. Cube root of 2 over 2. And if you use a calculator to check, it's about 0.63. Now here is, we are considering from 0 to 6. 0 to 6. I know it's caught up, but all the way up to 6, whatever this is, right? So you have these two area. This is an area, and also this whole area. I'm going to use different color. This whole area, because we are going all the way up to 6. Now here, these two area is some, right, 0 to certain point. Take a look at this. Remember, we want top and the bottom. The top function is this one over here, y equals 0, minus the bottom function, which is our 8x cubed minus 3. Now, as soon as you hit this point, it switches. My top curve is your green curve, and the bottom one is black. So we have two regions. So my area that I want to calculate, my total area end up being the orange curve, the yellow one, plus the blue one. Okay, it's not just one area. We have to add them up, and we have to divide it because our top is on the yellow region, y equals 0, and then bottom is 8x cubed minus 3. But as soon as you go past that cube root of 2 over 2, it switches. Blue one is on top, and then black one is on the bottom. So I want, whenever you are setting up the equation like this, my recommendation is pull out a graphing calculator, graph the two functions, and identify which one is top and bottom. Sometimes the piece can be just one of them consistent, so you don't have to add them up. This time, you have to do it separately because the top function switches, and this happens often. So let's do yellow one first. Let's focus on the yellow one. Remember, we want the top minus the bottom one. So the yellow one is from 0 to cube root of 2 over 2, right? Cube root 2 over 2. Top is the black one minus the bottom one. So I have a top minus 8x cubed minus 2 dx. Okay. Now the blue one is top. Now it starts at now cube root of 2 over 2 all the way up to 6. Our ending point is 6. top now is the blue curve, which is 8x cubed minus 2 subtract 0 dx. Okay. So that's the setup. Now all I have to do is, just like chapter 5, we apply the fundamental theorem of calculus and evaluate sum those two areas. So let's do that. This part, distributing the negative, I'm going to have cube root of 2 over 2, negative 8x cubed plus 2 dx. Cube root of 2 over 2, 6. This will be 8x cubed minus 2 dx. Okay. Raise power divided by new power, easy one to evaluate. So if I raise power divided by new power, that will be reduced down to negative 2. X to the fourth. 2 will be 2x from 0 to cube root of 2 over 2. Same thing, raise power divided by new power. I'm going to end up having 2x to the fourth minus 2x. Evaluate from cube root of 2 over 2, 6. Okay. Fundamental theorem of calculus, right? You have this f of cube root of 2 over 2 minus f of 0. And same thing over here. I'll just use g because they are different function. G of 6 minus g of cube root of 2 over 2. And then we are going to sum that up. So let's plug it in those numbers. After plug it in, it's going to look like 2 cube root of 2 over 2 to the fourth power minus 2 cube root of 2 over 2. And then I'm not going, subtracting 0, this will be just a 0. So that's it for the first part. I'm not going to write that. So that's this whole thing right here. Subtracting 0, I'm not doing anything. Adding, let's do this one over here. 2, 6 to the fourth minus 2, 6. And then there's the subtraction. Minus 2, raise it to the, let me make, let's resize it a little bit. Okay. 2 times cube root of 2 over 2 to the fourth minus 2 times cube root of 2 over 2. And that will be the whole blue one right over here. So my area, simplifying, whole thing, putting into calculator, I have 2592 minus 12. Final answer, 2580. Okay. So it's not so much different. This whole process right over here to here is what we did in chapter 5. What makes it different is the setup. You have to decide which one is a top curve so that you subtract top minus bottom to keep a positive area, because area is always as measured as positive. So we have a bunch of practice problems, 7 problems. I'm going to leave second one for you to try, and I'm going to do the third one with the exponential, because 2 is very similar to number 1. But final answer end up being, I'll still give you the answer, the whole area ended up being 77.5. So check that. All right. All right, now let's take a look at number 3. Here's the 2 curve again. I'm going to be using the calculator just to see. I have the visual representation of which one is a top and which one is a bottom. And I'm going from 0 to 2. So let's enter that right over here. The first one is 8 e to the x, which is, and then minus 5, and then bottom one was 0, and we are only considering this time 0 to 2. Let's graph it. Oh, this is nice. Why? You have just a single curve. Blue one will be always on top and then all the way up to 2, right? All the way up to 2. It's only blue one always top and then black one on the bottom. So very simple, no intersection. So that's a very simple one. My area will be, remember, this was a top curve and this was the bottom one. End up going to be 0 to 2, 8e raised to the x power minus 5 minus 0 dx. This one is also very easy to evaluate. So I have 0 to 2, 8e to the x minus 5 dx. Evaluate term by term. So 8e to the x minus 5x from 0 to 2. By the fundamental theorem of calculus, we can substitute and subtract the two value. So my f of 2 end up being 8e squared minus 5 times 2 minus 8e to the 0 power minus 5 times 0. So they want you to round it to the 3 decimal place. So first one, put that whole thing in the calculator. I get 59.1124488. I just round it to the little bit more decimal place. Minus 10. This one is a 0. E raised to the 0 power is 1, so minus 8. So my final answer at the end, I'm getting 41.112. This number 3 was very simple because there was only one area, no intersection, consistently from 0 to 2. It was a blue one on top and then black one on the bottom. Okay. All right. Moving on. So again, more practice, and then there are a couple practice that you can also look at in PowerPoint as well. So number 4 is I'm leaving it out for you to work on. This is very similar to first problem. You have to graph it, and there's a point of intersection where it switches top and bottom. Okay, your area ended up being 221/6, rounding to the 3 decimal place, 36.83. So this is your try on your own problem. Okay. All right. I'll do number 5. Okay. And then I will leave number 6 and number 7 for you to work on. These are all just more practice. The concept is exactly the same. So I'll do number 5, and then you guys can try number 6 and 7. So number 5, let's graph these two. We have x squared minus 10, and then we have 15. Because it's going all the way up to 15, I want to adjust the window to y max maybe 20. Let's just see what happens. And then maybe increase x to 10 just to see what's happening here. All right, so we have this curve right over here. Okay, so I'm having, there are 2 intersection points, right? Looks like first intersection point is about, where blue and green, 5. And then second intersection point is all -5, right? Because of symmetry, right? And we can do the math to double check. So we have this symmetry going on, and then they are intersecting twice from -5 to 5. And I'm going to capture this one. And then pull it out on the notes. And let's comment about this a little bit. And you can do some algebra and then check. If you set x squared minus 10 equal to 15, add 10 to both sides, you're gonna get x squared equal 25. As soon as you square root, you get this double positive and negative. So that's right, 5 and then -5. Okay. Now the reason why I did this one is because they didn't give you the interval, right? They didn't ask you to do it in certain intervals. So we are just looking at the whole thing, whole picture. Because this is a symmetry, there's really 3 areas to consider, right? If you look at it, you're going to see definitely this area, right? One area that you can consider is this one. Okay. And the other area is right over here. And then this one here. Now the reason why I colored it in pink for both sides is it's consistent. So I'm just going to calculate this yellow one and then double it. Then I'm going to get the right side too. Okay. And look at the yellow one. Yellow one, top curve is a blue and then bottom one is black. But in the blue region, you have the top curve black and then bottom one blue. So you can see that this is another switching part, right? You have this switching thing going on. So let's set up the problem. I'm going to take a look at this area over here. So normally what we would do is this one keeps going, and then you get to the negative infinity, right? It's the beginning all the way up to -5. But since we didn't learn infinite integral yet, for the purpose of this one, we are going to be focusing on the blue one, okay? Later on, we'll learn the infinity, going all the way up to 0 to infinity or negative infinity to some b, okay? But for now, we didn't learn infinity, so I'm going to only calculate this blue area, okay? So that will be -5 to 5, and then the top curve is 15, subtract x squared minus 10 dx. Then I have -5 to 5. Distribute 15 minus x squared plus 10 dx. Adding up, I have -5 to 5, negative x squared plus 25 dx. Term by term, I'm going to have this one, -x cubed over 3 plus 25x from -5 to 5. Okay, so we have fundamental theorem of calculus. Plug it in. I have -5 cubed over 3 plus 25 times 5. And then minus -5 cubed 3 plus 25 times -5. Let's do some algebra. Plug it into a calculator. I have -125 over 3 plus 125. Subtract 125 over 3 minus 125. I have 250 over 3 minus -250 over 3. I get 500 over 3 as our final area answer. Okay? All right, more practice problem. Try on your own for 6 and 7. The answer ended up being for number 6, 29.167. And then for number 7, I got area as a nice whole number, 72. Okay. All right. 9 and 10. Actually, 9 and 10 is exactly the same. 9 and 10, 8 and 9 is very similar to number 5. 1 through 7, they ask you just graph it and then do it, but I've been using the calculator to check. That's what it is. Problem 8 and 9, use a graphing calculator to find the intersection point. Then find the area between the two curves. So number 8 is very similar to number 5. But I'll just do it one more time with you. And then number 9, you're going to be practicing on your own. So I'll pull out the calculator. Okay. And then let's pull out calculator. Graph the function. For number 8, we got x cubed. And then another one, we have 9x. Let's just use a standard window. And you can kind of see that, oh, we might have an intersection if I keep going up. So I might want to increase some y. Because I see that black and blue curve will eventually like match up at the time. So I'm going to slightly increase just to see where the intersection point is. So I'll just do, I don't know, negative 30 to 30. Let's see if there's an intersection. Oh, yep. Intersection is right over here around y value 25, 26. And same thing will happen here, negative 25, 26-ish. So let's copy. Okay. So you can see that we have two areas to consider. Two areas will be here. I will color it. The orange one and then the green one. Orange one, let's comment a couple things. Orange region, top will be the blue curve minus black curve. Green one, you have top is a black one minus the blue one. So this is what we've been doing. So 8 and 9, it's nothing different. Here we have to find a couple points. There are 3 intersection points. The 3 intersection point is here. I'll use red. First point, second point, and then the third point. Okay. Now the intersection point that I'm going to be using, you can use, you can set up, of course, x cubed minus 9 equal to 9x. Then you can subtract x cubed minus 9x equal to 0. Factor out x, x squared minus 9 equals 0. Zero product property, we have set it equal to 0. So one of them is x equals 0, so that's this one. Add 9. X squared equal 9. So square root, I have a positive and then negative 3. So this is a negative 3, 0, and then positive 3. So let's do the setup. My orange area will be negative 3 to 0. Blue curve was the x cubed. So I have x cubed minus 9x dx. Add them up with my green one. green one starts from 0 to 3. Top curve is a 9x minus the bottom curve, which is x cubed dx. So that will be my entire area. Okay, very simple one to integrate term by term. So I'm going to be integrating the orange one. So x cubed, so raise of power divided by new power, minus 9x squared over 2 from negative 3 to 0. And then the green one, same thing, 9x squared over 2 minus x to the 4th over 4 from 0 to 3. And then now then you have these f of 0 minus f of negative 3. And then you have g of, I'll just use a different letter, g of 3 minus g of 0. So we have 0 to the 4th over 4 minus 9 over 0 square over 2 minus negative 3 to the 4th over 4 minus 9 negative 3 square over 2. So this whole thing is your orange one. And then now let's do green. Oops. Green. 0 to the 4th over 4 minus 9 0 square over 2. Subtract. Let me make, let's make this small. You have 3 to the 4th power over 4 minus 9 times 3 square over 2. All right, simplifying. It's a zeros. 0 minus 0. And then the second parentheses, I get 81 over 4 minus 81 over 2. These are the zeros again. Minus, this one end up being 81 over 4 minus 81 over 2. So final answer, after doing all those algebra, I got 40.5 as our area. All right, so you can do the same thing using the calculator. Find the intersection point. I already did 2 problems, like number 5 and number 8. So number 9 is your practice, and your answer ended up being, the area I got was 30.375. So this is try on your own problem. All right, that's it for chapter 6.1. And then on the next lecture, we will learn rest of the chapter 6.